Under motion in straight line, we'll be studying two types of motions. One is horizontal motion, another is vertical motion. Horizontal motion will be covering, one is scalar nature, another is vector nature. Any movement or motion deals with only magnitude and no direction is a scalar. Where magnitude and its directions are considered and used for any measurement or calculation purpose are vector quantities. Under this horizontal motion, whether it is scalar or vector, will be covering uniform motion, non-uniform motion, average value and instantaneous value. Then kinematic equations, graph, then last is relative motion. Under scalar quantities, that is the distance, then speed, then average speed and instantaneous speed. Under vector motion, it will be displacement, then vector velocity, then average velocity, and fourth is instantaneous velocity. Distance is the actual path length or actual path covered by any particle or any object during its motion. The distance is equal to the actual path length, whereas displacement equal to difference between final position and initial position. That is, displacement equal to final position minus initial position. Speed is distance covered by time. Velocity will be displacement by time. Average speed is total distance or total path length by total time taken. Average velocity is final position minus initial position by total time. Average speed will be always greater than or sometimes equal to average velocity, as distance or path length will be always greater than or equal to displacement. In all cases, path length or distance will be more than displacement, except if the motion is in straight line and in same direction. that is from starting of the motion till end, direction remains same or direction never changes. In that case, distance will be equal to displacement. Again, if the motion is in straight line and in one direction, distance will be equal to displacement, or average speed will be equal to average velocity. Path length or distance will be some value. Displacement will have value positive or negative or 0. Same average speed will be always positive, whereas average velocity will be either positive if displacement is positive, negative if displacement is negative, and 0 if displacement is 0. If final position and initial position will be same, in that case displacement is equal to 0 and average velocity will be 0. Instantaneous speed is the speed at any particular time during motion. Instant velocity is same velocity of the objects at any instant of time, that is displacement by time, and time duration tends to limiting value of time tends to 0. This instantaneous velocity equal to dx by dt if x is displacement, dx by dt which is equal to slope of tangent at that point. Instantaneous speed will be always equal to instantaneous velocity. Any motion in which if the object covers equal distance in each equal interval of time is called uniform motion. In that case, instantaneous velocity is equal to average velocity at all instant of time. That means if the velocity remains same throughout the motion, It is called as uniform motion. If the velocity at each instant of time is same, it is called uniform motion. In that case, instantaneous velocity equals to average velocity at all instant of time. That means now we conclude displacement may or may not be equal to path length or distance. Distance is equal to path length, that is always positive, and it is more or equal to displacement. Displacement may be 0 or negative or positive, but corresponding path length will never be 0. If motion is along straight line and in same direction, distance becomes displacement, average velocity becomes average speed. In displacement time graph, average velocity equal to slope equal to, if x is your displacement, dx by dt, that is x2 minus x1, final position minus initial position, or the displacement by time period. Average velocity will be positive if xt graph makes a positive slope with x-axis. Average velocity will be negative if in xt graph the velocity makes negative angle with time axis or x-axis. In displacement time graph, if displacement is 0, that means position is always at same point and never changes. It becomes a, that position time graph it becomes a horizontal line parallel to time axis. In that case, velocity is equal to 0 as displacement is 0. When there is a change in velocity, with respect to time, that is rate of change of velocity, is termed as acceleration. Average acceleration is equal to change of velocity by time interval. That is final velocity minus initial velocity by time duration is equal to average acceleration. Instantaneous acceleration is equal to acceleration at any instant, that is change in velocity by time interval with limiting value of time interval delta t tends to 0. Then instantaneous acceleration becomes dx by dt. Which is velocity instantaneous acceleration becomes dv by dt, that is double derivative of displacement d square x by dt square. That is the slope of the tangent in velocity time curve. That is the tangent makes angle with the axis. Tan theta or slope of the tangent in Vt curve is the instantaneous acceleration. Average acceleration is equal to final velocity minus initial velocity by time duration. That is the constant value of acceleration. At every instant, value of acceleration remains same and it is equal to instantaneous acceleration. This is called as uniformly accelerated motion. That acceleration is equal to constant, this average acceleration, final velocity minus initial velocity by time, v minus u by t equal to a, where v is called final velocity, u is called to initial velocity, and t is the time period, and a is the acceleration, that is average acceleration. Then we get kinematic equations. V minus u by t is equal to a, or v is equal to ut. V minus u by t is equal to a, v is equal to u plus at. Another equation we get v square minus u square is equal to 2s, or v square is equal to u square plus 2as. In that case, as is the displacement. And another equation we get, s is equal to ut plus half at square. Under vertical motion, we will be covering upward motion and downward motion. If any object is thrown with some velocity upward, it does a upward vertical motion. Whether it is vertical motion, upward motion or downward motion, in both cases, acceleration remains constant, and that acceleration is acceleration due to gravity. During upward motion, initial velocity let u, and during the motion at any point velocity is v. Here acceleration becomes minus of g. V equal to u plus at, or v is equal to u minus gt. At highest position, velocity becomes 0, v becomes 0. In that case, our equation becomes 0 equal to u minus gt. T is the time taken from starting point to reach the highest point. Then T becomes u by g. Using formula of displacement S is equal to ut plus half at square, we can find the height from ground up to the highest position. H1 is equal to ut plus half gt square. In that case becomes g becomes minus g, and h1 becomes ut minus half gt square. During downward motion, for freely falling body, initial velocity is 0. When it touches ground with some final velocity. Initial velocity, if it is 0, it is called freely falling body, and during the motion, acceleration equal to g, that is acceleration due to gravity, and a is positive g, a is equal to plus g. Initial velocity may not be 0. In that case, if any object is thrown from any height with some velocity, in freely falling body, initial velocity is equal to 0, and during the motion, previously mentioned 3 kinetic equations are applicable. In this case, v square is equal to 2as plus u square, u 0, then v square is equal to 0 plus 2as, or v square is equal to 2 g h. and we can find out the velocity at which object will hit the ground equal to square root of 2g and h. H is the height from where it has started or initial position from ground, or the height you can say. H time will be taken, t we can get from s is equal to ut plus half at square, u is equal to 0, or if height is equal to h, our equation s is equal to ut plus half at square becomes h is equal to ut, that is 0, plus half at square, that is half gt square, then h becomes half gt square, or t becomes 2s by g underscore, under root, t equal to under root of or square root of 2s by g. In vertical motion, we found during upward motion, time taken to reach the highest point, t becomes u by g, where g is acceleration due to gravity and u is initial velocity. Maximum height will be attained, h becomes ut minus half gt square. Where t is equal to u by g. During downward motion, for freely falling body, u is equal to 0, s becomes half gt square, t becomes square root of 2s by g, and a v at which the object will hit the ground becomes square root of 2gh. The last one is in horizontal motion, that is the relative velocity. The relative velocity will be two types, maybe two vehicles or trains or crossing a river. When two vehicles are moving with different velocities, the relative velocity will be difference of that velocities. If both are in same direction, relative velocity VBA becomes VB minus VA, where VB is the velocity of object or vehicle B2, VA is velocity of vehicle B1. In special case, if VA is equal to VB, then VBA becomes VB minus VA is equal to 0. If both are in different directions, opposite directions, then difference of VB minus VA to becomes VB plus VA.